How can neurosurgeons be helped to remove brain tumours more accurately?
At this hospital in Las Palmas in Gran Canaria, Spain, complex surgery on a brain tumour is underway. And of course, the neurosurgeon's challenge is to discriminate between healthy and malignant tissue.
We can't often see how accurately much of the brain is actually affected by the tumour, so we don't know how much to remove. And that is a real issue because brain tissue does not regenerate. Brain damage is irreversible.
Exceptionally, telecommunications engineers have been invited into the operating theatre. They're testing a prototype hyperspectral camera designed to help neurosurgeons see details they can't see with existing technologies.
We can clearly distinguish the brain tissue affected by the tumour, here in red, from the healthy regions in green. We can also help differentiate other anatomical details, like veins for instance, that we see here in blue.
The help is much needed by neurosurgeons who often have to trust incomplete or inaccurate data produced by magnetic resonance or computed tomography.
We work with visual information about the brain tumour gathered before surgery, but meanwhile brain tissue can move, can reposition itself, and a brain tumour's dimension can also evolve. With these images taken during surgery, we know the location of the tumour issue for sure. So where and how was all this technology developed?
Scientists from a European research project developed the hyperspectral cameras in electronics labs like this one. Whereas a conventional camera captures images in 3-colour channels, red, blue and green, a hyperspectral camera captures data over a large number of spectral bands.
It is a completely non-invasive technique. We don't need to inject contrast agents. It is also a non-ionizing technique, so we don't change the properties of the brain tissue. And it provides the surgeon with lots of information in real time during surgery.
Real time is a key issue. Scientists aim at providing neurosurgeons with processed images in less than 1 or 2 minutes. That needs advanced computing tools.
We are here working with machines whose processes team up to reach a certain specialization. That way, processes become really effective in dealing with the algorithms that decide which brain tissue is affected by a tumour and which is not.
Scientists hope the technology will be ready in around 2 years. After lengthy and complex clinical trials, it could be on the market in around 5 years.
We hope that in the future, these cameras will be much smaller, so we can embed them into surgical microscopes. That way, we will be able to see simultaneously the real picture of the brain and the hyperspherical images of the injury. The next step is to use this technique in other tumours, in the lungs, breast, or the colon. We dream of launching a brand new specialism that we would call hyperspectral medicine.